Okay, so the second part of the problem asks us to create an amortization schedule for each group of bonds. This part is very mechanical, and you get lost in the details very easily, but it makes our job much easier down the line when we go ahead and we try to account for the interest expense and to report the value of the bond on the balance sheet in subsequent periods. So it makes our job much easier if you can understand these calculations as I go through them. You'll be so much better off for it. So I'm going to walk you through each group of bonds, the first one, the second one, and the third one, and what the amortization table would look like, and try to comment along the way why we're doing what we're doing. And the first one is super easy. It's the group where the bonds sold at face value or at the par value, and we can't forget the contract that we've signed and agreed, which stipulates the size of the payments we're going to make along the way and the interest rates and so forth, which becomes important in the amortization schedule. So the first grouping of bonds say that we will pay, us being the debtor, 10% annual interest. Since we're paying every 6 months, it'll be 5% interest. And so we're going to pay 5% every 6 months, 5% of the face value of $1,000,000. So we will pay $50,000 every 6 months. We will do that a total of 10 times because it's a 5-year bond. And so you can see my amortization table here has several columns and many rows, one row for each payment. And the very first row up here is not for a payment, but it's just to kind of lay out what's going to happen when we acquire or issue the bonds. So when we issue the bonds, we're not going to pay any interest yet. There's no interest expense. This is what happens on January 1st. And actually, if you look at this problem, I kind of have a typo in how it's laid out. We aren't going to pay interest on January 1st of 2016. The very first interest payment that we have is going to be July 1st of 2016, and we'll make another interest payment on January 1st of 2017. And and that has a subsequent, very substantial change in how this problem would take place if the company paid interest on the very first day that we issued the bonds. We didn't. So the bonds should say that we make interest payments every 6 months starting July 1st of 2016. So when we issue the bonds January 1st, no payment, no interest. There's been no discount or premium amortized, and actually there is no discount or premium for this very first grouping of bonds. So the carrying value of the bond is going to be the face value of the bond, $1,000,000. That's what shows up on the balance sheet. The interest expense is going to be, because there's no premium and because there's no discount, it's going to always be exactly the amount of the cash payment. Very, very, very simple. There is no discount, there is no premium to amortize, so nothing here that we have to consider for this overpayment or this underpayment. And so there is no discount or premium. And all the way through the life of the bond, the long-term section of liabilities of our balance sheet will always say $1,000,000 until we repay it on the very last day, and then it goes away. So this is what the amortization table looks like for the very first grouping of bonds. Very, very simple, no explanation really needed. When we get to the second grouping of bonds, it's much more difficult and harder to understand. So what changes in this? This is January 1st of 2016. For the second group of the bonds, we're not going to make a cash payment yet. There's no interest expense, but there's this premium, right? Because we received more cash than we were asking for. We were asking for $1,000,000 on the face of the bond, and our investors gave us $77,212 extra dollars. So we're thankful for that. But that gives us some accounting challenges that we've got to deal with. In that, how do we account for this? What is this? This is extra money. It's free money in essence, kind of, not really. But the matching principle says, well, this benefit that you received, the $77,000, you can't push that all through into 2016. That violates the matching principle. This bond benefits many, 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 many accounting periods, 5 annual periods, and so this $77,000 you should spread out over the life of the bond. So we take that $77,000 benefit and we spread it out over the life of the bond in some systematic form. Okay, so when we first issue the bond, we're not going to spread out any of the premium. And the carrying value now changes. It's not just the face value. It's going to be the face value plus the premium. and I actually have this backwards. Let me just, this column is supposed to indicate how much of the premium or discount we've spread out, which is 0. This is the amount of the premium or the discount that we have yet to amortize. So the carrying value of the bond when we first issue it is $1,077,212. So the balance sheet would show a total bonds payable of this amount. Right? These two accounts get netted together to show up on the balance sheet. So that very first interest payment period, now if I wasn't careful, I would have missed something, right? Because this is the second grouping of the bonds, and the agreement with the second grouping of the bonds is we'll pay 12% annually. But since we're paying every 6 months, I'll pay you 6% every 6 months of the face value. 6% of 1 million is 60,000, not 50,000. And so we'll pay 60,000 every 6 months. Now, here's where it changes significantly from the group 1. The interest expense is not 60,000. We got this benefit up front when we issued the bond of $77,212, and that benefit now needs to be spread out over the life of the bond. So the interest expense is actually smaller than 60 grand, even though we're paying 60 grand. The interest expense showed up on the income statement for this first 6-month period is less than 60,000. Well, how much less? If we're using straight line amortization, it'd be very simple. It'd be 1/10 of this because there are 10 payments, so about $7,700. But the straight line method is typically not the method that GAAP allows us to use. There are some exceptions, but we'll go through the effective interest rate method, which is the method preferred by GAAP because it's more accurate. So the question becomes how much, and that's what amortization means, how much of this 77,000 do we spread out to each payment period? And the way that we do this is the effective method says, okay, you take the market rate, 10%. Remember, we cut that in half to 5 because they're semi-annual interest payments. 5% of the beginning carrying value is what we're going to record as interest expense. You'll notice the difference between the two is $6,000. That's the amount of the discount that we're amortizing. So spreading out. So the discount, this is actually premium. The premium got smaller by $61.39. So the carrying value, which is $1 million, the face value plus the premium got smaller, and you'll notice it'll get smaller and smaller and smaller and smaller until it hits the face value, at which point we pay it off at the maturity date. So again, and we'll just repeat this is where it becomes very mechanical. The interest expense we're going to record if we have a bond that's issued at a premium is always going to be the discount rate, market rate, which is in this case it's 5%. So I'll lock that into my formula, times the beginning carrying value. The beginning of the interest payment period is the ending of the last payment period, times that one. 53. Notice it's changing, and the amount of the premium that was amortized or spread out is now changing, 64.46. So my discount or my premium has become smaller, 64,626. And again, carrying value is the face value plus any unamortized premium or discount. So watch what happens. This is the power of Excel. You have to do it by hand. I'll just carry these formulas forward, and bang, my amortization table is finished. You'll notice that the interest expense is getting smaller and smaller and smaller and smaller as the bond gets closer to maturity, and the amount of the amortized premium gets bigger and bigger and bigger. And what should happen, and this is a small rounding error, at the last interest payment period, the discount or the premium should be 0, and the carrying value of the bond should be the face value, and then it would get paid off. Okay, so that's the amortization table if there's a premium. Let's do it very quickly now if there's a discount. A couple things change. The discount amount instead of the premium is $77,222. We figured that out here from the prior part of the problem. The carrying value of the bond is no longer the face value plus the discount. It's the face value minus the discount. And the interest payments, the cash payments we make in the Group 3 bonds are 8% of the face value, which cuts down to 4%. 4% times a million means my payments are 40,000. Okay, so that's how much I'll pay over and over and over and over again because the contract says I have to. The interest expense becomes 5% because that's the market rate. It's always going to be the market rate times the beginning carrying value. Notice here it's larger. Let's just talk briefly about that. This makes sense because my cash payment, the interest I'm paying is 40,000. When I issued these bonds up here, I issued them at a discount, meaning I didn't get enough cash, right? I only got 922. I wanted a million. So I kind of got ripped off, right? I got 77,000 less than I wanted. This is the cost of putting the bond on sale. And the matching principle says you don't expense all of this extra cost in the current accounting period. The matching principle says you expense it over time. And so we're going to expense some of the $77,222 in the first payment period, and then some in the next, and the next, and the next, and this is how we come up with. So I would expect my interest expense to be larger than the cash payment. So the discount is going to get smaller by the amount that I've amortized, and again, the carrying value, which is the face value, minus the unamortized discount. Okay, so now again, watch what happens. The power of Excel will very quickly complete the amortization table for me. Yep, and this is exactly what I expect. The discount that we started with 77,222 should get smaller and smaller and smaller. It's like peanut butter, right? I'm spreading it out, spreading it out, spreading it out. It's all spread out at the end. Okay, so the value of the bond should get bigger and bigger and bigger and bigger until it hits the face value, and at which point the bond will become mature, we'll pay it off, and we'll owe exactly $1 million. It's neat how that works, right? And so the interest expense gets a little bit bigger, right? Because the farther out the debt is, the larger the the longer we're carrying the debt, the more the interest cost. So that's the amortization table. Take your time and go back through that as much as you need in order to become familiar and and make sure you really understand why is it bigger here when we're doing the discount as opposed to the premium, and what does all this stuff mean, the carrying value and the unamortized discount or the premium. These are important concepts that you'll see over and over and over in financial accounting.